Alright, so we need to find the integral of secant squared x minus 2 dx. So I would say it's not a bad idea when your integral has more than one piece to break them up, just to make sure that you get every single piece and you don't miss one. So the integral of secant squared dx is tan x, and then the integral of 2 is 2x. And since these are indefinite integrals, I have to make sure to put my constant on the end. All right, the second one says to find this first integral if we know that f of t dt evaluated from 0 to 8 is k. You might not really know where to start here, but I'd say just go ahead and start with this, with integrating that. So I said 0 to 2, because that's what we're trying to find, so might as well start there. So when I looked at this, this is actually U-Substitution, so you can see that your inside function is x to the third, and then we have this outside, right? So I'm going to say that u is x to the third, and then the derivative of u is 3x squared dx, and I can see that that actually shows up in the problem. So that means that what I'm doing is I'm integrating f of u du, and I'm not going to say I'm integrating it from 0 to 2 right now, because 0 to 2, those were x values, not u values. So if I want to change those so that they're in terms of x values instead, then I'm going to say that u is 0 to the third and u is 2 to the third, like that. So 0 to the third is 0, 2 to the third is 8. And then what I notice is that this is exactly the same as this. It's just using a different variable because I did U-substitution, and up here it's kind of like they did T-substitution. And so that means that when I evaluate this, I'm actually going to get K. So this goes back to a concept we didn't look at too deeply. If you guys recall those days that we did U-substitution with a definite integral, we just made sure that when we wrote it as U-substitution that we didn't put the 0 and the 2 back since they were in terms of x, and we would do our U-substitution, we go back and substitute whatever it was back in, and then we would go ahead and put those x values back there to evaluate it. Well, I showed you guys that every so often you're going to run into problems where you're not going to be able to plug the x back in to evaluate it, and you're going to have to figure out what your interval is, what you're evaluating it with in terms of u. And so this is how you do it. And the reason that I remembered that when I was taking this is because I actually ran across that in my notes. I remember doing that in my notes, and I made sure to put that in the packet because I was reading about it, and I was like, oh, they could do that to us. So if they give you an original integral in terms of x, and you're going to have to do U-substitution, and you want to know what your new interval is, you just have to take this U-substitution right here and plug your original interval into it. So 0 to the third, 2 to the third. And if 0 was right here, then whatever you got when you plugged it in should go on the bottom. Whatever you're plugging in on the top should go up here. You don't reorder the numbers to go from smallest to biggest, because it's possible when you plug them in for your u that they will be in the wrong order, and that's the right order for that specific problem. I can't remember, but I feel like it happens again on the test, so I'll make sure to point it out. All right, number 3. So this one is using one of the fundamental theorems of calculus. I can't remember if it's the first or second one. And I always remember that because these have 2 different variables. So if you're given that f of x is this integral, then f prime of x is, we just take the integral and we plug x squared in for it first. So we have x squared plus 3 times the derivative of x squared, which is 2x, minus, and then we plug in 0, 0 plus 3 times the derivative of 0 is just 0. And if you guys recall, this always happened where like we plugged a number in second and it like zeroed out pretty much every time. So that means that we have 2x, x squared plus 3. C. All right, number 4 says, what is the average value on the closed interval? So the average value, if you remember, is 1 over b minus a. So, and that's the interval, so we have 1 over pi halves minus 0. And then we're integrating sine x times 4 to the cos x, like this. So that gives me 1 over pi halves, which is, I can flip that pi halves up, and so I've got 2 over pi. Oh, and I forgot my integral here. 0, there's my interval, I need my dx. Okay. And then if you look at this problem, we're going to see that this is U-substitution. So I'm going to use my U, because otherwise I wouldn't know how to integrate that. So my U is cos x. My du, the derivative of cos, is negative sine x. And dx. And I don't have a negative in front here, so I need to divide by negative and pull a negative out to the front. So that means that what I'm actually integrating here is negative 2 over pi 4 to the u du. That's what I'm integrating. Now, when I looked at this, I was like, oh crap, I do not have that one memorized. So that might be something to star, put on a flashcard, make sure you memorize that integral, because it could show up. So we are going to have negative 2 over pi. When I looked up the integral of 4 to the u, I realized that that was 4 to the u over ln 4. And so that gave me negative 2 times 4 to the cos x of pi ln 4. And we're evaluating this from 0 to pi halves. Now here's where I got this answer wrong. So I plugged pi halves in my head, and I was like, oh, cos of pi halves is 0, so that zeroes out the top. That does not zero out the top. So I ended up getting this one wrong. It's negative 2 times 4 to the 0, and 4 to the 0 is 1. So just be careful of that. I made that mistake. Negative 2 times 4. Cos of 0 is 1. So what we have here is we've got negative 2 times 1, which is just negative 2. Plus 8 over pi ln 4. So if we have a common denominator there, which is nice. When we add those together, we get 6 over pi ln 4, which is the right answer. All right, for the next one, it says, what is the value of the integral from negative 3 to 4. So if you guys remember that the area, or that an integral is an area, so what they're doing is they're asking you to find the area of this curve. So I went ahead and I called this area A, and I called this B, and I called this right here area C, and I called this D and E and F, so that I kind of knew what formulas I needed to be using to find my areas. Now this depends on, since you obviously can't just evaluate it in your calculator, and you can't really do it by hand either, like as far as like integrating the actual function and then plugging the numbers in, you have to understand how the areas work here. So when you're finding an area of just one function, you're not finding an area between two functions. Then if the curve is underneath the x-axis, that area is negative, and if the curve is above the x-axis, that area is positive. So to make my life a little bit easier, I first noticed that D and E are the same area, but one is negative and one is positive, and those are going to cancel each other out. It's like perfect, I don't have to find that one. For this one, I noticed that this is a quarter circle, because they told us that, I mean, it looks like one, but then they also told us in the problem that that was a shape that's on there. So I said that A is going to be 1/4 pi r squared, and I could see that my radius was 2, so I said this is 1/4 pi times 2 squared, and so that would be 1/4 times 4 times pi So that area is pi. It's underneath the x-axis, so it's negative. Now for b, I can see the area of 1 square is a unit, and so b is half of that, so I know that b is positive 1/2. C, I can see that's 2 boxes, so I said that was 2. You can be using the formulas for this if you want. You could do 1/2 times base times height. You could do length times width, that sort of thing. But you could also just count the squares. And then F is another quarter circle. So we've got 1/4 pi r squared, which is 1/4 pi times the radius is 1. And so that's 1/4 pi, and again it's underneath, so that's negative. Alright, so here's what I noticed. I was like, I've got 2.5, which is 5/2. And then I was like, I've got -1 and -1/4, which is -5 pi/4. And if I wanted to combine these together, then I need a common denominator, so I multiplied that by 2/2. So that gave me 10 minus 5 pi all divided by 4, which is all right, number 6, and we can use our calculator. So here it says to find a region. Here's our function between the x-axis and the lines x equals 0 and x equals 4. We want to use the trapezoidal rule and have 4 equal subdivisions. So if you guys remember the trapezoidal rule, it is 1/2 times the height of the trapezoid, which happens to be the width of the subintervals or the subdivisions. So if you are going from 0 to 4 and you have 4 subdivisions, they're each going to be 1. And then the formula was f of the smallest one plus, and then we do 2. 2 times f of 1 plus 2 times f of 2 plus 2 times f of 3 plus, and then 1 of the last one, plus f of 4. And then what I did is I went ahead and I took this function and I plugged it into my calculator, into y equals, and I didn't graph it, I just looked at the table. So I could see that I had 1/2, and then it was 4 plus 2 times 21 plus 2 times 56 plus 2 times 115 plus 204. And when I plugged that in, I found that the answer was 296. Alright, number 7, they want us to find the original function if the derivative is this. So for us to go from a derivative back to the original function, we need to integrate. So I've got 2x over x squared minus 1. And this is a U-Substitution problem. So my u is the x squared minus 1. My du is the 2x dx. And so that means that what I'm integrating is 1 over u du. So I went ahead and did that. The integral of 1 over u du is just ln u plus c. And then we can plug the u back in. And they gave us an initial value so that we could solve for c. So I know that if I plug in 2, I get 0 as an answer. So 2 squared minus 1 plus c equals 0. This is ln of 4 minus 1, so ln of 3 plus c equals 0. So that means that c must equal negative ln 3. So that means that our function is ln of x squared minus 1 minus ln 3. So 7 is B. All right, The mean value theorem. So for the mean value theorem for integrals, we use the average value of the integral. So, which makes sense, right? Because mean is another word for average. So I'm going to say 1 over b minus a, and the integral is from 1 to 3 of 2 ln x. And you do not have to do this by hand because we're able to use a calculator for this. So I went ahead and plugged it into my calculator, and I found that this was 1.296. So now what we have to do is we just have to solve for c, which is the x value that's on that interval. So I took the original function, 2 ln x equals 1.296, and we're making sure either that you have stored this decimal in your calculator or that you're typing it in using the original decimal, you're not using the rounded. I went ahead and divided each side by 2, and that gave me ln x was 1.296 divided by 2. I just had that number in my calculator. I might have stored it, I can't remember. And then to solve for x, you just have to do e on each side. So whatever you get when you plug that in, that's the answer. And you could have used the stored decimal for this, or you could have been kind of keeping it going as you go along. But it's 1.912. So C. All right. Now if you look at this one, what I ran into is, since this was calculator active, I just went ahead and plugged it into my calculator. The answer I got on my calculator did not make sense. So I went back and I looked at the problem and I thought, we just got to double check some things. So one of the things we have to double check is for me the clue was E. Oh, it's possible that this is an improper integral and that maybe you have to like do it separately, like break it up a little bit. And so I looked at this problem and I said, well, what would make this something that you couldn't integrate? And it's the bottom. If the bottom equaled 0 on the interval, that would be a problem. So I took the bottom, the denominator, and I set it equal to 0 just to see when that would happen. So it's a 5th root, so I'm going to go ahead and raise this to the 5th power. So 2x to the 3rd plus 1 equals 0. And then I'll go ahead and minus the 1 over. So 2x to the 3rd equals negative 1. And then I'll go ahead and divide the 2 over. X to the 3rd equals negative 1/2. And then I'll go ahead and take the 3rd root of that. So the 3rd root of negative 1/2. And you can 3rd root a negative number. It just is saying what times itself 3 times equals negative 1/2, and that's possible since you've got a negative times a negative times a negative. And this is approximately negative 0.794, which is on the interval, which is why you can't integrate that. So remember when we did these, when we were doing improper integrals, that we could find the limit of the integral, but we couldn't find the actual, like you can't actually evaluate that. All right, let's look at this one. I got this one wrong, not because I couldn't do the problem, but because I didn't notice this x right here. So just be really careful to read these. Sometimes if the problem feels like maybe it's a little bit too easy, I don't know. I didn't feel like this one was too easy, even ignoring that x, but just so you know it's easy. It was possible to miss it. So what I saw here is I saw 1 to 3 and 1 to 7, and then I saw 3 to 7. And so I was like, okay, there's some combination going on here of like this one and this one makes this one, that sort of thing. So I looked at this and I said, all right, I know that the integral from 1 to 3 plus the integral from 3 to 7 is going to give me the integral from 1 to 7, like that. And 3 to 7 was the one that I was trying to solve. And if you notice, these numbers are backwards. So you do have to use the property of integrals. But I went ahead and started it off like this. So I said 1 to 3 is k. This is the one I'm trying to find, and this equals negative 4. So k plus something equals negative 4. So then I said my something equals negative k minus 4. And then I knew that my something was for the integral from 3 to 7, and they gave us the integral from 7 to 3. So if you guys remember, when you take the numbers and you put them backwards like that, it just is the negative number. It's the negative version of your integral. So then I knew that mine, if I was going from 7 to 3, would have been the negative version of this. So that is positive k plus 4. Now, I left that as my answer because I didn't notice this x right here, so you got to be careful. So now that we have that, we can go back and finish the problem. So 7 to 3 of x plus f of x dx. So we're going to go ahead and say the integral of x is 1/2 x squared plus, and then we know that this one, actually I'm going to write this a little bit differently. I'm going to split it apart into 2. Might be easier to... Okay, so if I integrate this one, I get 1/2 x squared evaluated plus, and then I already know that this one is k plus 4. So now I can go ahead and evaluate this. I've got 1/2 times 3 squared minus 1/2 times 7 squared, and I know I'm going to be adding it to that. So 1/2 times 3 squared is 9/2. 7 squared is 49, so minus 49/2. And is this calculator active? You can just add that in a calculator if you want, put all those numbers together. Or you can say that's negative 40/2, which is negative 20. So negative 20 plus 4 is negative 16. So k minus 16 is actually the answer, or negative 16 plus k. That's the case maybe. Tricky. They tricked me. All right, next problem. So for this one, they want us to use 3 left-hand rectangles of equal width, and we're going from negative 3 to 3. So this is a width of 6. That means that every 2 we are making our interval. So I said from negative 3 to 1, from negative 1 to 1, from 1 to 3. And if we're doing left-handed for our width, or for our height, I mean, then these are the left-handed heights. So we're using the left side of the interval instead of the right side of the interval. So I said that I'm going to do 2, because my width is 2 for my rectangles, 2 times the different heights, 1.25 plus 0.53 plus 1.04. I plugged that in a calculator and I got C. All right, initially a water tank contains 100 feet cubed of water, and the water begins to drain. How many cubic feet will remain in the tank after 3 hours? So this is using another definition of the integral. So we always think of the integral as the area underneath the curve. One of the other definitions of the integral is that you can use it to find net change or accumulation or total displacement or things like that. And that's the situation that we're using here. So we're saying what's the accumulation of the water that's coming out of the tank. So I went ahead and set up the integral from 0 to 3 of 30 e to t divided by 3 divided by 1 plus e to t over 3. And I went ahead and just plugged this in my calculator since we are still calculator active, and I got 55.810. You will notice that is an answer. It's the wrong one because that's how much water you've lost. So then I took 100 and I subtracted that decimal, and I got 44.190, which is the answer. All right, now we're going back to not being able to use a calculator. So here in number 13, they told us that we have an even function and we have an odd function, and then we have this kind of interval thing going on right here. So what I did is I wrote down, we've got from negative a to positive a, so I went ahead and I split this up. So I said I've got 2 times s of x dx minus r of x dx plus 3 dx. Right? And then it's pretty key that you need to know if they're even functions or odd functions. So here, when it's an odd function and you go from negative a to a, odd functions have areas, part of the area is going to be above the x-axis, part of the area is going to be below the x-axis, and they have symmetry there, and so the areas actually cancel out, and this ends up being 0. So that's good to know. When it's an even function, the areas actually end up doubling. So, and you can go back and look in your notes if you need to do that. I can help you look that up. So, so this is, it's not plus, it's minus. Minus, so this would be double. Well, this one was over here, which was 5, so we're subtracting off 10. And then over here, I've got plus. Now the integral of 3 is 3x, and that 3x needs to be evaluated from a to negative a. And so here I've got 3 times a minus 3 times negative a. So that's 3a minus negative 3a. That's 6a. So negative 10 plus 6a. And so 13 is B. I accidentally took up all my space. All right, in this one, I don't know if you guys would have recognized this, but I was looking at this and I was like, man, these are real similar, is how I felt, because 9 goes to 81 pretty nicely. So I tried rewriting this, and I saw that this was 9x over 1 minus 9x, and then I was thinking about how to get the 4. So I was like, if I do 9x squared, and then I square that whole thing, then I could see that 9 squared is 81, and x squared is x to the 4th. And then when I looked at that, I was like, that looks like one of the inverse. It looks like it has to do with one of those inverse trig functions, and then I looked at the answers and I was like, oh, yeah, it does. So I already know it's not A and it's not B. And the nice thing is you don't have to know which inverse function it is because they gave it to you. It's sine inverse. So now you just have to go through and do the problem correctly. So when I looked at this, I was like, okay, this is going to definitely be U-substitution. So I've got U is 9x squared. And du is 18x dx. And I don't have an 18, I do have a 9 though, so I can go ahead and just divide this by 2. Alright, so that meant I've got 1/2 in the front, and I've got 1 over the square root of 1 minus u squared du. And then I don't really have to know what the integral of that is because they gave it to me, it's sine inverse. So that's 1/2 sine inverse of u plus c. And then I can go ahead and plug my u back in. 1/2 sine inverse of 9x squared plus c. So I think if you look at the problem, it would have been easy to kind of shut down on this one. But if you guys noticed, they bailed me out of the hardest part of it. They bailed me out of having to know which inverse it was. They could have been mean and put like all different ones. And I've noticed they tend to do that sometimes, like on the problems where it's 1 over u and you have to do the ln. You guys often, that was your mistake, you often integrated that wrong, but I've noticed on problems like that, ln is in like every single answer choice. So, or most of them. So as long as you remembered it was ln, then you could do the problem correctly. So as long as you remembered that this one needed to be an inverse function, you didn't have to remember which one it was, you just had to be able to integrate it correctly. So be careful of giving up too fast on the problems where you're not exactly sure what to do, because it might be possible to just do them. All right. This one, so says the graph is shown and it consists of 3 line segments and 1 semicircle. So we're saying that g of x equals this function. So they're giving us that fundamental theorem of calculus again. And they are asking us about these statements. So I'm going to go ahead and just do the fundamental theorem of calculus on this. I'm going to say g prime of x is f of x. So I'm plugging in the x times the derivative of x is 1 minus f of negative 2 times the derivative of negative 2, which is 0. So that zeroes out. And so g prime of x is f of x. So this is the graph of f of x, which means it's actually the graph of the derivative of g. Okay, so keep that in mind. I kind of ignored a and b because I was like, I don't really even know how to work with those. So I kind of ignored those to start with. And then I jumped down here. So I said, is g prime of 6 1? I said, well, that's the same as asking, is f of 6 1? And I looked over, f of 6 is 1. Yep, that's true. So it can't be this one. We're looking for a false statement. It says g of x has a relative maximum at 4. So that means if g of x has a relative maximum at 4, then its derivative should be switching from increasing to decreasing, right? Or not, that's what the relative maximum is. Since the original function switches from increasing to decreasing at 4, then our derivative should switch from being above the x-axis to being below the x-axis at that point 4. And if you look at 4, it's above the x-axis the whole time, which tells us that the original function would have just been increasing that whole time. It would have been increasing through 4. It would not have switched from increasing to decreasing. So D is definitely the false statement. You can stop there, obviously, because you found it, but if you want to maybe feel a little bit better about it, I noticed here we have a point of inflection at x equals 2, so you can kind of think through that at x equals 2 for it to be a point of inflection. The derivative has to switch from increasing to decreasing or from decreasing to increasing. And if you look at the picture, you'll notice it does do that. It switches from decreasing to increasing, so we know that that was true. And then I didn't really know what to do with these, but I felt pretty good about my answer, and then it was right. Okay. So if we look at this one next, it says, we're going to use a calculator here. The acceleration of a particle is given as a of t. And we've got some typos here, these should be t's. That's the variable they want us to use. Is that on the closed interval from 0 to 3? So it says find the velocity, and I was like, perfect, I know how to do that pretty well. So for part A, I knew that I had my acceleration, so my velocity is going to be the integral of my acceleration, so 3e to the t minus t to the 4 dt. Now it says to find it at time t if, and it gave us an initial conditions. That means we're going to have a plus c on the end because we have an indefinite integral. You'll notice I'm not using the endpoints. I'm not using 0 and 3 to evaluate this because the problem said to find the velocity at any time t. They want the formula. And they gave us an initial condition so we can solve for that c. So the antiderivative, or the integral of e to the t, is just e to the t. You leave that coefficient in the front. And then with this one, I'm adding 1, so that gives me 5. So minus 1/5 t to the 5th plus c. And then I went ahead and plugged that point in. So I said if I plug in 0 for the t's, I get 6 as an answer. And so that zeroes out right there. Anything to the 0 power is 1. So 3 times 1 is 3. 3 plus c equals 0. So c equals negative 3. Oh, that's a 6, not 0. Goodness gracious. So that's a 6. Minus the 3 over, we get 3. Sorry about that. So that means that v of t is 3 e to the t minus 1/5 t to the 5th plus 3. And they were careful right here to put the units with the function, so I'm going to go ahead and put units here, centimeters per second. I'm just matching them with that. Okay, so that's part A. The points for this problem, 1 point was given for doing the integral, and then the other point was for the answer, and this is the correct answer. All right, part B says find the position of the particle, and I'm like, yay, I know how to do that. So I'm going to integrate the velocity. And you can separate these if you want and do them like individually, or you can do it all together. It doesn't really matter. So the integral of 3e to the t is 3e to the t minus, I'm going to add 1 to that, that's 6. And if I divide by 6, that's like putting a 1/6 in the front. So that's 1/30th t to the 6th plus 3t plus c. And then they also gave us an initial value, so they said plug in 0, you get -5. So 3e to the 0 minus 1/30 times 0 to the 6th plus 3 times 0 plus c equals -5. And so I got 3 plus c equals -5, and so c equals -8. So now, now I can write my position particle. And they said x of 0, so they're telling me to use the variable x. So I said x of t is 3e to the t minus 1/30th t to the 6th plus 3t minus 8. And the position vector would be centimeters for the units. So again, B is worth 2 points, 1 point for doing the integral, 1 point for the answer. All right, for part C, it says, is the speed increasing or decreasing? And this is where you have to remember that the acceleration and velocity vector tell you if the speed is increasing or decreasing. If they're the same sign, it's increasing. If they're opposite signs, it's decreasing. And that would be your reasoning that you're explaining. So you can go ahead and write something like that. I don't feel like wasting video time writing that. And that's actually what that's the reasoning that they have written in the answer key for this. So if they're the same sign, they're increasing. If they're different signs, they're decreasing. And then all you really need to do is just plug in 6.5 to the acceleration function and to the velocity function. So when I plugged in 6.5 to the acceleration function, I got 210.362. When I plugged it into the velocity function, I got negative 322.156. And since they were opposite signs, I said that overall the speed was decreasing. So, and if you want to think about it like literally, you didn't have to write this as part of the answer, but if you want to think of it literally, it means you're accelerating in the negative direction, right? Because you are accelerating and you're doing it in the negative direction, so that means that's like slowing you down overall. So this was a 3-point problem, 1 point for this, 1 point for that, and then 1 point for explaining that the signs either needed to be the same or opposite to determine the answer. All right, for D, on the closed interval from 0 to 3, what is the velocity of the particle when its acceleration is at a maximum? So acceleration is at a maximum. So with that, I knew that I needed to look at my acceleration function, and to find the maximum of my acceleration function, I needed to take its derivative. So I'm not thinking of what the derivative of acceleration means. I'm not thinking of, is this like velocity or whatever. I'm not thinking of that. I just know that when you take the derivative of the acceleration and set it equal to 0, that's how you find your critical points of the acceleration function. So I did 3e to the t minus t to the 4th. That's the original function. So my derivative is 3e to the t minus 4t to the third. And I know I'm going to set that equal to 0 so that I can solve for t. And they're telling me to use the interval from 0 to 3. So what I did is I don't know how to solve that equation by hand. So I graphed that on my calculator and I made it so my x min of my window and my x max of my window went from 0 to 3. I know that this curve could cross the x-axis multiple times, but I only care about where it crosses on that interval from 0 to 3. So since I'm setting it equal to 0, I'm solving for x-intercepts, and I found that the x-intercept was 1.49593336. And I wrote down all these decimals because typically on this exam you should not round your answer until the very end. And I didn't want to, since I'm going to have to use a rounded number, I wanted as many decimals as possible for when I do my calculations. So now I said, okay, that was the only point. It means, and you can look at the graph, you can see that it goes from being above the x-axis to being below the x-axis. So that means it went from increasing to decreasing, which means it really was a max. And now I can go ahead and just evaluate my velocity vector using that decimal. And when I did, I got 14.892. And so I just explained that the maximum acceleration was this, and you can explain how you found it. And then I just plugged it in. I just kind of explained the process that I used, because this is a 2-point problem, 1 point for the answer, 1 point for the reasoning. And I don't know if you showing your work would be reasoning enough, but I went ahead and did a little bit of explanation because to me it felt like this was kind of bare, and then it really was a 2-point answer. So I don't know a ton about how the AP exam is graded, but I'm kind of making guesses here or there to make sure that we get all the points.